Howdy and welcome back. So let's kind of begin by just looking at what a set is. And the reason why we're going to really briefly define sets is because we're going to define our graphs as a set of vertices and edges. Keyword there being set. So what is a set? I'm not talking about the set data structure here. I'm talking about the set as a concept as it presents in mathematics. So we'll define a set as a collection of distinct objects, none of which is the set itself. Without thinking about this too mathematically or reading too much into that definition, for the purposes of this class, just think about a set as being just what it sounds like. So a collection of some sort of things, a set of some sort of things, a set of silverware, a set of baseball cards. When we get into graphs, it'll be a set of vertices, a set of edges. So some sort of collection. And that's going to be the focus point here. I just wanted to make sure to introduce this notion of a set before we begin defining things in terms of a set. In mathematics, a set's usually going to be denoted by listing the names of the objects separated by commas within a pair of braces. So in this case, we can see the set A. It's containing three distinct objects, Howdy, CS, and 128. And I may or may not kind of use this representation to list out the vertices of, say, a particular graph, the edges of a particular graph, which is why I'm presenting it here, so that when that happens, you know that we're talking about a set of these distinct objects and understand how to interpret that, what's being communicated there. So that's literally all I wanted to cover with sets. We're now going to define a graph in terms of a set. Then we'll begin looking at the basic types of graphs and a couple of properties thereof. And then we'll go ahead and close out with that introduction to how graphs can maybe be useful for storing different sorts of data within our program.